Okay, welcome everyone to this virtual cannabis conference. We're the last guys for the day, so hopefully you stick with us here. We have three presenters here talking about the opportunities for automation in the cannabis grow market. I'm John Kurtz with Accent PDIR.
Brenda Bergstrom, Accent PDIR.
Eric Ross, TC Controls.
So we'll be doing a tag team presentation. Hopefully you'll get some value out of this. And if there's any questions, just put it into the Q&A format on the side of your screen. So to kind of give us a little bit of a background on the cannabis market, the grow market, it's certainly a market that's been growing, sorry for the pun, a lot lately, as more and more states are legalizing either medical use or full recreational use. So the other thing is that the plants themselves, they need a lot of water, about 6 gallons a day. They need consistent light and nutrients to grow well. So with all of this projected growth, we are projecting kind of that it's going to be from a mix. This extra capacity is going to come from a mix of either new add-on facilities or getting increased yields from utilizing automation. And the facilities that we're working in have varying degrees of automation. So there is a lot of opportunity to increase the level of automation in those facilities.
Yeah, so typically in a large-scale facility, you'll have a major automation system. On the grow level, the automation system will control irrigation, fertigation, environmental control, temperature, humidity, CO2, light levels, all the processes that have to happen in the grow space. With irrigation in particular, that's the lifeblood of the plant. The water quality, the nutrient levels need to be pretty precise to get the best product. And that's where sensing comes into a factor, where water sensing and control systems can control those levels that growers are looking for. So the grow facilities usually have pretty large water rooms, a lot of water storage, and fertigation systems that are constantly running and creating nutrients for their irrigation system.
And we'll be talking about a lot of the different parameters that they're measuring. Eric mentioned several of them, particularly on the water side, the connectivity, dissolved oxygen, moisture content, water flow rates, and tank levels, and things like that. But the other, important considerations in the automation is that beyond having a good design and installation is the service and the aftermarket and the support and the training on how to operate those facilities efficiently and effectively. So we'll be touching on those points as we go forward, and kind of giving you some guidance as to what maybe stocking of spares for the various probes, as far as ones that are consumable, and then what you might need on hand for each one of these to calibrate in the field.
Yeah, and connecting these sensors to an automation system that you can actually control to is a huge time saver for cultivation team. I think we're trying to do this very labor intensive and a lot of spot checks and constant calibration with with good equipment, industrial type equipment. You are able to have that consistency in the output of what you're controlling. So good pH sensors, conductivity sensors, EC sensors, the dissolved oxygen, and temperatures are very crucial in creating those recipes.
So we break it down into a couple different areas. The environmental parameters, which are looking at the environmental conditions of the room that the plants are in. Temperature, humidity, moisture content, lighting, of course, and then other primary and secondary process parameters that are important to the grow, as to the pH and the conductivity of the water coming out of the fertigation skids, dissolved oxygen in that water, CO2 levels, and then being able to track and maintain and control the flow through these systems so that you're getting the right amount of nutrients to the plants when they're expecting it.
And having your water mill tanks, so you'll usually have an RO system or some kind of filtration system that's filling clean water tanks. Then that has to process through a fertigator to either direct feed right to the rooms, or you're going to feed into or mix into batch tanks, which will then feed to the rooms. And all those processes, sensing the levels, sensing flow rates, and these elements, with different sensors, are somewhat crucial to having an efficient system run and making sure you have enough water for the next day's irrigation cycle. Make sure you have enough nutrients on hand to provide what the plants need, and then when it's all connected to a control system, you'll have the ability to trend that history and create alarms if something isn't operating correctly. So the cultivation team doesn't have to sit in the water room and monitor these things manually.
Yeah, with the overall goal being that we're looking for consistency and repeatability of the process, which is going to then lead to consistency and repeatability of the product. So all of these, are being monitored and then also controlled to make sure that you're keeping them in the ranges that you desire for the optimal growth of your plants.
Yeah, environmental temperature humidity is very crucial, and cultivators will want to keep the plants, they kind of follow a VPD chart, and that temperature humidity is crucial to maintain those levels as the plant grows, matures, and the nutrients, the different nutrients they use to create different strains and have that unique strain and unique quality over and over is crucial for high quality sensing.
Do you want to mention anything about the recommended manufacturers for these environmental sensors?
Yeah. So in the grow rooms, we have temperature, humidity, CO2. A lot of times we use light level to monitor light intake for plants, moisture content for soil to see how the plant is, grabbing that water. Some of the common manufacturers that do environmentals, most large grow control systems will have their own environmental sensors. We probably recommend using them with those control systems, but there are plenty of third-party sensors. There's, Greystone's pretty heavy in the cannabis. There's some canopy sensors. Apogee is a high quality sensing company that can provide environmental sensors and lighting sensors, and moisture content there. I think Apogee has a moisture sensor. There's a host of sensors that do moisture content, DC level, temperature.
When you get down to the process parameters, this is more related to on the water side of the process. You want to maintain that pH with pH sensors, inline pH sensors, checking the fertigation effectiveness with the connectivity, and the level of dissolved oxygen in the in the water. Make sure you have enough there, and then the CO2, both from a perspective of what's in there in the room for the plants, get the optimal level, but then not have too much, so that you're not putting your workers at risk. Some recommended manufacturers that have been in play in the cannabis markets on the pH side, Signet, Sensorex, ATI, Walchem, the connectivity sensors. Typically, we're using the it can be either contacting or electrodeless connectivity. The electrodeless ones are a little easier because the electrodes aren't exposed to the water and they're not getting corroded over. The electrodeless ones can withstand a little bit more buildup of dirt from the water from Signet, or again the same kind of players, Sensorex, ATI, or Walchem. Dissolved oxygen, ATI is used frequently on the gas side. ATI can offer a solution there, as well as some others.
For dissolved oxygen?
For CO2.
Oh, CO2. CO2, yeah, there's E+E makes a great robust sensor. Greystone makes a great CO2 environmental. CO2 meter has a very good sensor for grow rooms where they have, I think, a 30 or 50,000 ppm sensor that can actually control things directly with relays. They also have a remote display that you can display levels outside the room. And a host of, you can go to more inexpensive sensors that are used commonly in regular BMS building automation systems, but they're not quite as robust as some of the grow ones.
Signet does offer the DO sensor as well. So we have ATI, Pyxis, and Signet for the DO sensor.
Oh, right. For these sensors, most of them they're pretty sturdy and robust. The pH sensors and the CO2 sensors do operate under a process where they have, the sensing part is considered a consumable. So those should definitely be, you should have spares on hand so that you can change those out as those deplete.
Yeah, they have a shelf. They have a operating life that the documentation will, recommend replacement times for. Those should be a common stock item on the shelf, and any major growth.
Right, and any of the other sensors are probably, if you have one extra on hand, that's probably enough to get started. But certainly you should have more on the consumable spare side for the pH and the CO2 sensors.
And this is all stuff that, as you purchase, and if it's your first time or you've been using it for years, both of our companies are perfectly capable of doing any training, servicing, and even if you just have questions, getting things going, or if you're looking for a new solution, that's something we definitely can help with as well. So it's not just a purchase and go. I mean, this is the support and service and training that you need for any of these products.
And that training would also include important things like calibration of the sensors as they continue on. Timing of that calibration schedules, that usually is kind of determined by, we kind of say the authority having jurisdiction. In this case, that's usually the grower themselves as to how much they are confident in the instruments that they have. But usually it's anywhere from maybe every week, every month, every quarter, depending on the actual instrument that is being used.
Yeah, and it's crucial to check the calibration. Spot check the calibration of most of these sensors. Biannually or on some kind of maintenance schedule to confirm they're accurate. Because if you're controlling to a sense value and it's not accurate, you have no way of knowing if your product is coming out the way it should be.
Right, and you really should be calibrating based on standards. So for like example, pH, that's going to be calibrated against the pH standards of, usually you can get standard solutions 10, 7, or 4. And using any combination of those two, you can do a 2-point calibration fairly easily on a pH sensor, depending where you're operating typically, either above or below 7. The electrodeless conductivity, dissolved oxygen, and those others, those are usually calibrated against handheld instruments that you have then calibrated in your lab, and you trust those. So that is, you have to have some kind of calibration standard that you can trust, and then that's what you're setting these instruments against, or calibrating them against.
Yep, and environmental, you want to spot check your temperature, humidity, CO2 sensors in the grow rooms to confirm they're accurate as well. And the manufacturer will have recommended life expectancy of certain sensors. You want to make sure you're checking, before that.
Mm-hmm. Other parameters that you would typically want to track, the flow of the water into different areas of the plant, or different rooms down to specific plant or pot. And then be able to control that flow to maximize, minimize, or I guess optimize the flow of that water to the various areas. Measuring level in tanks, either as an overall measurement from empty to full, or having some level switches in the tanks that will keep you from overflowing tanks, or running tanks dry and burning out pumps and things like that. So on the nutrient feed side, there's a couple different ways to get those nutrients into the water. One way is like with a dosatron pump. It's really it's kind of using inductive technology, and there's not many moving parts there. It's pretty simple to operate, pretty easy to set. But if you want a little bit more precision in the addition of your nutrients, then you might want to look at some metering pumps, either peristaltic or diaphragm, to get those nutrients into your water. And then if you do end up with the peristaltic pumps, they have tubes in them that do need to be replaced on a kind of a regular schedule, usually probably on a every 6 to 12 month basis, depending on how frequently they're being utilized.
Yeah, and on something like the flow in a control system, if you can monitor that flow and record it for history, you can determine if you're overwatering, underwatering, based on your soil levels in the rooms, and optimize that flow so you're not wasting, not over wasting water. Level, it's crucial to make sure you have full tanks to have the availability of water to water that day or the next day, and nutrient feed. Obviously, if you do go with a manual kind of operation with dosatrons, where you're relying on differential pressure to pull nutrients in, you should put pH and EC sensors after those dosatrons so you can confirm that they're mixed to the right levels. And typically we see EC, pH, temperature after dosatrons, and sometimes flow meters to confirm that.
Okay, so kind of reviewing why we measure all these parameters. We're really looking to maximize the efficiency of the grow, and really by doing things in a consistent and repeatable fashion, and being able to monitor so that you can see where things are actually operating, and then change flow rates or change addition rates in the, say, for example, in the fertigation, or turn the fans on or off for better HVAC. Without the base information, you won't be able to make those kind of decisions as to, well, I should cool off the room a little bit, or I should add more water to these plants today. And so all that's trying to get a consistent quality product by controlling the addition of all these raw materials. And one of the most important raw materials is your manpower. If they're running around trying to write down the readings on all these different point devices, that's just maybe not the best use of their time. And then you're absolutely interjecting potential for human error if they write down the wrong number, or they transpose two numbers. It happens.
Human.
Yeah, the computers tend to not take too many days off. They don't want to go to the beach. So they are much more reliable, consistent, and they will also then log all that data so that you have that data to do some trending and tracking and predicting and forecasting later. It's also very important for the various state and federal regulatory agencies that you need to be concerned with. You have all that information, then you can put into reports to verify that you're operating in a safe and efficient manner.
Yeah, and the having these sensors control the equipment that's doing the work. In some facilities that we've worked in, we have growers that can pretty much do everything from home with their control system. They can fill tanks from RO, they can do batch tanks, they can water plants, and they're very confident in the result. And as you know, plants are 24 hours. They don't. They still need water, and they still need environmentals. In an indoor grow, constant. So a control system can monitor that 24/7 and control it 24/7. But having the ability to log in remotely, at night, weekends, and feel confident that the systems are doing what they need to do is, huge labor savings and peace of mind for a cultivation team.
Yeah, or getting alerts that, hey, there's a problem.
Right. Oh, yeah.
In the middle of the night.
Sure.
So
Absolutely.
So you don't end up losing a whole batch or something like that.
Right. And you can lose a room very quickly, especially in the light cycle where you have all this energy with lights and moisture that it won't take long to, destroy some plants.
Yeah. So collecting the data and measuring all this is very important information. But if it doesn't go anywhere, then it's not really all that useful. So we're going to talk a little bit here, a couple slides of kind of the various points, because all these are kind of point devices out in the facility, out in the environment, and some are what we call blind. They don't have any readings to them that are local, and others, as shown in the picture there, you might have a local reading, but if every one of your sensors had a local reading and you needed to run around with a clipboard to track all that down, that's a pretty inefficient way to collect all that data. So sometimes what we've done in facilities is we collect for one grow room, say, or one area in a grow room. We might have a local point where we bring back a bunch of instruments, bring them into one enclosure, and have multiple displays. And in this case, in the picture shown, it's showing. It's tough to see because it's so small, but it's showing like 4 different instruments all in the same there, so the operator can see those things that are most important to him, and then he can tweak the system from there.
Yeah, and then taking that information and having it communicate to a control system or even just a monitoring system that can trend an alarm and email information out to cultivators. So this slide kind of represents a control network in a grow facility where this particular one has Argus controls, and basically all those controlling sensors go back to these control panels. They all get networked together to the facility's computer network, which is connected to the internet. So cultivators can log in and control the system via a network terminal, and also remotely log in to a system and do the same thing. All these controllers will be programmed to control the various elements and fertigation systems and irrigation systems to provide what the grower wants for environmental and recipes.
Okay, and then there's various places where you can store the data. You can do it in local area controllers, so you can do it kind of on room or area basis. As Eric said, then sending that back to a central BAS system for the entire facility, and you're logging it there. And then sometimes for redundancy purposes, you might want to put it out on the cloud, so that if you lose power or you have problems with your central servers, you're not losing all that data.
Yeah, and a lot of controls will have some history and some alarming capability. It's usually pretty limited. A central server system will be able to capture all that information, and a lot of systems will be cloud connected. So connectivity and storage, can be automatically put into the cloud storage systems that are very robust.
So we have a couple projects we just wanted to go over with you, kind of share what parameters were being measured and just the benefits and how these companies that we've worked with benefited so far. So we had one in PA. And this is actually a two-stage project. So we started with just adding the point watch or the point
Sensors.
Yes, sorry. With displays, this was the first step in automating a little bit more for this company. So, the pH and the temperature and dissolved oxygen and conductivity, we added displays to everything that they could. And that did help with some of the manpower and keeping it a little more accurate. Not so many having those displays there. They wouldn't have to go back to the panel or the controller that it goes to, read there and then come back. It just keeps them more in one area. Now we have upgraded. They have upgraded some of these systems to the second picture on the slide that we showed with the panel, the enclosure with the two Signet displays sticking out the front. So they have collected all of these points, brought them back to one location to where their workers or the employees can just go there and collect and write down and log or see all of the information in one spot. If you have 4 tanks and you're trying to measure all of these parameters at each tank, going to one spot on these locations where the enclosures are with the displays is much easier than sending someone to each one and having to look at 25 different parameters all through the room. So one of the benefits there was definitely making it easier, logging all this data and being able to see it just by walking by.
That helps to verify calibrations. You got to go to each tank and check it individually. It would be pretty labor intensive, depending on water rooms are usually pretty, full with piping and tanks and stuff. So having this one location definitely helps that.
Yeah. And we brought all these instrumentations to this facility in this project. And Eric, what happens after they collect all this data?
Yeah, so they take this data. It goes into a control system. That control system is actually controlling, injecting, the elements to get to the levels they want, and having these sensors in this particular scenario, they're all at batch tanks. So they're creating a batch tank of a specific recipe that has a large capacity that they can use for their complete facility. But what they want to do is make sure it's very consistent, growth cycle after growth cycle after growth cycle. So their product is very consistent. If this was a manual operation, every harvest, the product would be a little bit different. You really need constant, a very consistent levels and nutrients and things like that. So.
And this was a pretty big project. That's 150,000 square foot building facility. So, they started a little small and then realized that the more automated they could be, the better off the outcome was going to be for them and for their plants. So the growing for the next phase is working in their favor. Another one that we did was in Ohio. just a little under about 100,000 square foot for this one. And, even with this one, on top of all of the other things that we have, that we did with the other ones, we also did flow and level for the batch or for the tanks. And that, of course, having the switches for the level to tell you when it needs fed or filled, sorry, it is very important. And we have ultrasonic radar or ultrasonic level sensors that we can get in there, right down to just a little switch that says full or empty. So the level of automation is dependent on how close you want to watch your water usage. Of course, there's always the temperature and the humidity, pH, connectivity. This project also had them all brought back to one collection point for displays. So it seems to be a theme that we're running into. Customers really like having all that data in one spot. It seems to be saving them a lot of time and money to do it that way.
Yeah, it might look expensive in the beginning to create this infrastructure, but the long-term savings and quality of the product will pay for it very quickly.
And everything that they're measuring here, any issues at all that they have, if they have any, and there's not a lot, to be honest. We're right there, and they can call us anytime. We can come out right to site if they need and help troubleshoot or help, give installation guides and training right on site if that's what y'all need. So I think that's one of my favorite parts, actually, knowing that these systems that we're and the parts that we're selling to our customers, I like being able to help afterwards with any questions and issues or services or calibration or any of it.
Yeah, the support's pretty important. Cultivation team might not have the expertise to know how to calibrate or know how to change a sensor if it needs to be changed, and that's something that TC Controls or these guys can definitely assist in that process.
We're just going to mention one more project here, a little bit smaller of a facility at 75,000 square feet, but not smaller with the automation. Measuring a lot of the same parameters, but at the same time, they can fit a lot into one building, and that's quite a big facility anyhow. So they have moved from blind sensors up to the displays to the flow meters and paddle wheels to watch for the flow. Again, with the levels important to keep an eye on. I think watching your water quality and nutrient addition, that it's helping with a lot of that, just to really keep tracking and keep it consistent.
Yeah, and these three examples were pretty large facilities. There's no reason why a 20,000 square foot or even a 5,000 square foot grow facility couldn't utilize some of these technologies.
Doesn't matter, in other words, if it's 5,000 or 150 or 200,000, it doesn't matter. The benefits are the same, just in different quantities.
Yeah.
So, in summary, the cannabis grow market is here and it's growing fast. So it's our belief that the automation, investing in that will help you make your facilities more efficient, improving yield and quality on your end product, but also, enabling you to be as efficient as you can, so that the facilities don't have to be any larger than possible, because moving the air, moving the water, that all comes at a cost. So it'll help you also reduce your costs of some of your raw materials. And using that data, if you have that data, it's logged, you can use that to do your reports, but also do trend analysis and see about improving your recipes and things like that as you go forward. And I'll let you talk about the remote communications.
Yeah, and on the cost of fully automated grow facilities, as these states come online and new grow facilities are constructed, the cost of the product is usually at the top of the scale, when it comes into the state, let's say. So when you build a facility with full automation, the capital expense to build that facility, might look a little extreme, but you want to get all that capital expense in the beginning while the product can support it. So then when the product does come down to market value, your facility is running at the most efficient, and you're producing at a very low cost compared to someone that doesn't have a full automated system. It's the long-term effect of having less labor, having a product that's consistent and good quality, throughout throughout years after the build. So it's something to definitely think about. A lot of people get a little scared with having a fully automated system and spending the money, and they can do some of it by hand. We see that all the time where they put the money in up front, and they're able to produce the cost per pound that they can produce from these fully automated systems is a lot lower than other facilities.
Yeah, being the low cost producer in any market, of course, makes you then more competitive.
Yes.
As the margins start to decrease, as the market becomes more more competitive, I guess.
Yeah.
So.
Yeah.
And as we were saying, the predictability is key. It's collecting the data, using that data, making good decisions. That's all going to be very important going forward.
And remote communications, having the ability to connect these systems, monitor, get critical alarms, trend history remotely is very, very key for, especially a head grower that might have a team of cultivation people that are running the facility, and multi-state operations. He might be managing 3 or 4 different facilities, and obviously traveling to all the facilities and checking things is would be pretty labor intensive. So having remote connection and able to see all the parameters he wants to see and control the parameters they want to control is crucial.
So if you have any questions, please do enter them into the Q&A folder, and we'd be happy to answer any of those. Well, thank you for attending, and thank you for your time today. And we look forward to assisting anybody who wants to up their game on automation in their grow facilities. Thanks, everyone.
Thanks a lot.
Thank you.